What do the various refrigerant numbers mean? Believe it or not, there is a method to the madness. First of all, most refrigerants are organic compounds, which mean they have one or more carbon-hydrogen or carbon-carbon bonds. The only series classified as inorganic or lacking these bonds is the 700 series, which includes ammonia, carbon dioxide, and water. Most of the organic compounds used as refrigerants are hydrocarbons, meaning they are composed of carbon and hydrogen. Common examples of hydrocarbons are methane, ethane, propane, and butane.
Okay, a hydrocarbon is any molecule that has a carbon bonded to at least one hydrogen atom. Carbon and hydrogen are both very common elements in this world that we live in, and so therefore hydrocarbons are very common compounds that we find. They happen to be really good refrigerants as well, which is why we're discussing them here. Here's the most simple of the hydrocarbons. That's methane, or CH4. You can see we have a carbon in the center. Carbon is special in that it has 4 valence electrons. It's going to bond to 4 different atoms. In this case, all of them are hydrogen atoms, so hence CH4. It's kind of easy to see how hydrocarbons develop. If I were to draw this one here, a carbon bonded to another carbon, and all of these connected to hydrogens. Very, very similar molecule, except 2 carbons now. This we would call ethane gas. Probably heard of it. If we add a 3rd carbon, I won't write in my H's on this, but all of these are bonded to hydrogen molecules. We would call this propane, which we've all heard of. And then finally, I'll do one more. If we were to have a 4th carbon, all bonded to hydrogens, like that, we would call that butane. And an effective way to remember this, little clever thing I was told when I was in high school chemistry was mother eats peanut butter. And that's how you can remember how these hydrocarbons develop or build on each other. So if that's helpful to you, maybe you'll remember it 20 years from now, just like I remember it from 20 years ago. That's like the basics of hydrocarbons. Now, when it comes to refrigerants, most refrigerants, synthetic refrigerants, are hydrocarbon based, but due to the flammability that hydrocarbons present, scientists have modified them. So for example, if we take the methane gas, CH4, and we manipulate it by getting rid of the H's and instead bonding the carbon to chlorine and fluorine, which are two atoms from the halogen family, we now have a refrigerant, which is known as R12. Of course, this is a banned refrigerant, but it's simple to show. This refrigerant R12 was widely used in the early days of refrigerant. The name of it is dichlorofluoromethane. That's a mouthful, better known as R12, but you can see how it's kind of based off of methane gas. But by adding the 2 fluorines and the 2 chlorines, it removed its flammable properties.
Hydrocarbons are highly flammable, so scientists in the 1920s discovered that by trading a halogen atom for one or more of the hydrogen atoms, the resulting compound would be safer to use. Halogens are the elements in the second column from the right on the periodic table. Chlorine and fluorine are common halogens that have been historically used in refrigerant compounds. These new refrigerants were named halogenated hydrocarbons. Over time, that name was shortened and they became known as halocarbons, a term still used today. Here's an overview of the 9 series of refrigerants. The 000 series is referred to as the methane series. Each compound in this series has a single carbon atom. The 0 in the hundreds place of the refrigerant number in the series is omitted, so this series of refrigerants only has 2 digits. R12 and R22 are 2 of the refrigerants in this series. The 100 series is the ethane series, and each compound has 2 carbon atoms. R134A is a well-known refrigerant in this series. The 200 series is the propane series. Each compound in this series has 3 carbon atoms. The 300 series is the butane-based cyclic organic compound series. You've probably guessed it by now, but compounds in this series have 4 carbon atoms. The 400 series is reserved for refrigerant mixtures called zeotropes. Zeotropes tend to separate during boiling, which causes the refrigerant to have a temperature change, called a glide, during boiling. The 500 series is for a different group of refrigerant mixtures called azeotropes. Azeotropes boil at a constant temperature and therefore behave similarly to pure refrigerants. The 600 series of refrigerants is for miscellaneous organic compounds, such as butane and pentane. As mentioned earlier, the 700 series is for inorganic compounds such as ammonia, water, carbon dioxide, and sulfur dioxide. There is also a 1000 series of refrigerants that is reserved for refrigerants with unsaturated organic compounds. Unsaturated means that the organic compounds have 1 or more carbon atoms linked by a double bond. Now let's examine the meaning of the refrigerant numbers. The first digit on the right, or in the ones place, is the number of fluorine atoms in the compound. For example, R22 has 2 fluorine atoms. The second digit to the right, or in the tens place, is 1 more than the number of hydrogen atoms in the compound. Looking at R12, we see that there is a 1 in the tens place, so that means that R12 does not have any hydrogen atoms. The third digit to the right, or in the hundreds place, is 1 less than the number of carbon atoms in the compound. Propane, which has a refrigerant number of R290, has a 2 in the hundreds place, which means that the compound has 3 carbon atoms. There's a fun little trick called the rule of 90, which works as follows. If you add 90 to the refrigerant number of any refrigerant below R400, the resulting numeric value will tell you the number of carbon, hydrogen, and fluorine atoms. Applying the rule of 90 to R22 works like this. 22 plus 90 equals 112. This tells us that R22 has 1 carbon, 1 hydrogen, and 2 fluorine atoms. Remember, this does not work for the 400 through 1000 series refrigerants.
The rule of 90 is kind of like a fun little trick that works for refrigerants with a refrigerant number less than 400. And it works like this. If you add 90 to the refrigerant number, you will be able to determine how many carbon, hydrogen, and fluorine atoms there are in the chemical compound. So let's try it. So let's say we have refrigerant R134A, and I've written the chemical compound up there as well. Of course, nobody has that memorized. I grabbed that from a textbook, but I've written it up there. So let's do the math, which is pretty simple here. 134 plus 90. You see the answer there, simply put, is 224. So what does that mean? Well, that means there are 2 carbons, 2 hydrogens, and 4 fluorines. Now let's compare and make sure this is the right answer by looking up at our original formula. You can see there are, in fact, 2 carbons, there are 2 hydrogens, and there are 4 fluorines. So that's a demonstration of how the rule of 90 works.
The 700 series is for inorganic compounds such as ammonia, carbon dioxide, and water. In this series, the 7 in the hundreds place simply identifies the refrigerant as an inorganic compound. The final 2 digits are the molecular weight of the compound. For example, ammonia is refrigerant number R717. The first 7 indicates that it is an inorganic compound, meaning it has no carbon-hydrogen bond. The 17 is the molecular weight of ammonia, which has the chemical compound NH3. Nitrogen and hydrogen have molecular weights of 14 and 1 respectively. And we can easily see that 14 plus 1 plus 1 plus 1 equals 17, hence the refrigerant number of R717.